Although our knowledge remains incomplete, a great deal has been discovered about what happens in the brain during sleep, what areas of the brain become active or quiescent, how cellular activity changes, and which neurotransmitters, chemicals that carry signals between nerve cells, are released or blocked. Much has also been learned about the so-called biological clock, a small group of cells that keep our sleep-wake cycle running on about a 24-hour rhythm. This clock controls not only sleep, but also variation in just about every other physiological system throughout the day. The cells that constitute it lie in a primitive area of the brain, the hypothalamus, that also controls many other important automatic functions, such as hunger, thirst, temperature, and hormone levels. Nevertheless, we do not fully understand why we need to sleep, what causes us to sleep, and what purposes sleep serves. There can be no single answer to these questions in any case, because how you answer them depends on the level at which you approach sleep and waking. At the most basic level, that of neurophysiology, we can say we sleep and wake because of changes in the brain's chemical environment and in its cellular and electrical activity. On a higher level, that of function and behavior, we can say we sleep because sleep serves a restorative function for our bodies and perhaps our minds. Sleep certainly is necessary for us to function properly during the day. If we don't get enough of it, we feel sleepy, and this feeling can only be relieved by sleep. Finally, from an evolutionary perspective, the purpose of sleep lies in the benefits it provides for our survival. We can say, as various researchers have, that the purpose of sleep is to protect us from nocturnal predators, to rest the body, to maximize our alertness during the day, or to allow us to process memories. If we turn the whole question around and ask, why do we ever stop sleeping and wake up? We could also answer in terms of physiology, because of chemical and electrical changes in the brain, or of function, behavior, and evolution. We need to be awake to eat, procreate, and care for our young. Until the 1950s, doctors and other researchers believed that sleep was a single state, distinguishable only from waking. However, we now know that sleep itself is divided into two distinctly different states: REM, pronounced as a single word, REM, or rapid eye movement sleep, and non-REM sleep. During non-REM sleep, you lie quietly with a regular heart rate and breathing pattern. It is probably closest to what we usually think of as sleep, and it provides most of sleep's restorative properties. There is very little dreaming in this state, if any, although thought-like processes may continue. In REM sleep, physiological systems are much more active, and it is in this state that we do nearly all of our dreaming. During the night, you cycle back and forth between periods of non-REM and REM sleep, as well as having the usually brief, occasional waking. Non-REM sleep. After the earliest months of life, non-REM sleep divides further into 4 distinct stages. These stages range progressively from drowsiness to very deep sleep, and they can be identified in the laboratory by monitoring brain waves, eye movements, and muscle tone. As you begin to fall asleep, you enter stage 1, the state of drowsiness. Although you are unaware of it, your eyes move about slowly under your closed eyelids. Your awareness of the external world begins to diminish as well. You have no doubt had the experience of becoming drowsy in a lecture or meeting. As you nod off, you miss some of the speaker's comments, yet you will jerk awake instantly if your name is called, or if your head bends so far forward that you are about to fall off the chair. You might think you hadn't been asleep at all, if it weren't for your lapse of awareness. On waking from this drowsy state, you might remember some thoughts of the kind usually described as